Today we're going to talk about using scientific notation within a problem. So we've learned about converting scientific notation into standard form and standard form into scientific notation. Now we're going to involve scientific notation inside of a problem. So what we have to remember is that we can still use the different laws of exponents that we've already learned, such as product of powers and quotient of powers, to help us solve these. Now, I have attached a video which does a really good job explaining how to figure out multiplication and division of scientific notation. I have linked that video in your Schoology account, so if you want to watch that, get on Schoology, find a link, and watch that. But we're going to do a couple of problems just to demonstrate how this works. The first one, we have two scientific notation numbers being multiplied together. We can simply rewrite this because all of this is multiplication. We have multiplication here, here, and here. So I can rewrite 1.1 times 2.5 times 10 to the negative third times 10 to the ninth. 1.1 times 2.5 is simply 2.75. And then with the base, we have got two powers that have base 10, here and here. And product of powers tells us that powers that have the same base that are being multiplied, we can simply add the exponents. So I would do negative 3 plus 9, and that would equal 6. So I know that my 10 would have a power of 6. So my answer to this one would be 2.75 times 10 to the 6th power. That is a pretty basic example of how to multiply two numbers in scientific notation. One other example is a little bit more complicated, has one more step to it. In this problem, we'll do the same thing. We'll multiply the two numbers out front times each other, and then we'll multiply the powers of 10. 7.2 times 1.6 is 11.52. And then we can add these two exponents because we are multiplying powers of 10. 3 plus 4 equals 7. So I'll be multiplying by 10 to the 7th power. So we are done. The only problem is this is not written correctly in scientific notation. As you can see, 11.52 is greater than 10, and it needs to be between 1 and 10. So what do we do? Well, there is a very simple solution. If you look at this chart or diagram at the bottom of your screen, it helps us to remind what happens when we move decimal points and what happens to the exponents. So I'm going to move this decimal point one more time to the left. That'll give me 1.152. And as we see down here at the bottom, if I move the decimal to the left, the exponent gets bigger. So I will change the exponent from a 7 up to an 8. And my new answer is 1.152 times 10 to the 8th. So the only difference between this example and the previous example was that the answer was not written in proper scientific notation, and we had to adjust the decimal point to make it proper. Go ahead and try the got it's in the middle of that page that go along with problem number 1.